Today's video will explain how the mediator design pattern works. Hello, I'm James Helfrich. Oftentimes, a program has many different components which need to communicate with each other. The problem is, if there are n components, there are n squared possible communication avenues. The mediator design pattern is designed to solve this problem by making a single unified path through which all messages flow. The mediator design pattern is a message passing strategy where all control logic for the entire system is localized into a single location, and that location is called a director. So let's say I have 4 members of the Marine Corps. I have a captain and 2 lieutenants. Now, how many different communication avenues are there? Well, there's 1, 2, 3, 4, 5, 6. Notice with 4 nodes, there are 6 possible connections, and that seems manageable. I can deal with that. But now let's say we have some sergeants in here as well. Now we have a great deal, many more connections we can have. In fact, this is not going to even draw all of them, but with 12 nodes, there are 61 possible connections. It's an n squared relation. It's going to quickly get out of control. So what we need to do is find a new way to do this. What we want to do is put the captain in the center, and then all communications goes through the captain, and the captain is the mediator. So how are we going to implement this? Well, first of all, we're going to start with an object diagram. And the mediator is the object that sits in the middle of the connections, and it will connect to several colleagues. And we'll have colleague 1, colleague 2, colleague 3, and colleague 4. So the mediator will have a reference to each colleague, so the mediator can contact each colleague as needed. And the colleague will also have a reference back to the mediator, so the colleague can contact the mediator as needed. At this point in time, we have the communication, but we don't have the connection with the rest of the program. So the program is going to consist of, in this case, 4 parts: part 1, part 2, part 3, part 4. And these parts know nothing about each other or about the mediator and colleagues. So initially, I'm going to have colleague 1 have a reference to part 1, and part 1 will also have a connection to colleague 1. If I instantiate a part 1, I will also instantiate a colleague. In other words, this is composition. Part 1 will create and destroy that reference to colleague. And the same thing I'm going to do with part 2, part 3, and part 4. Now, if part 4 wants to contact part 1, it's going to tell its colleague. The colleague will then create a message, send it to the mediator. The mediator will forward up to colleague 1, and colleague 1 will then send it to part 1. And this is how part 1 and part 4 will communicate without any knowledge of each other. And that's the big win of the mediator design pattern, is the coupling is extremely loose between these different components. Okay, let's take a look at the class diagram. We're going to start with the mediator class, and the mediator class is going to have a collection of abstract colleagues. So we're going to have a notion of an abstract colleague, and there's going to be a reference to a colleague, but how many of them? Many, depending on how many different colleagues there are. And this is going to allow the mediator to contact the various colleagues. And the abstract colleague will have a reference to mediator. Now, abstract colleague can contact mediator, mediator can contact all the abstract colleagues. Notice how there's a many-to-one relationship between the colleagues and the mediator, and a one-to-many relationship between the mediator and the colleagues, and this is by design. If I want to send a message to the colleague, I will call the mediator : notify and send a message. And this will send a message to notify of the abstract colleague. Now notice this is a pure virtual function, which makes this an abstract class, and that's why it's called an abstract colleague. Well, if I have a pure virtual function, that means I must have a concrete colleague, in this case, colleague 1 and colleague 2. And these will all be related to abstract colleague through inheritance. And each of the colleagues will implement my notify message. Let's take a look at concrete colleague 1 here. It's going to have a reference to part 1. And so there must be a part 1, and this is part of the program that's going to receive or instantiate messages. So concrete colleague 1 will have a reference to part 1, and it'll be exactly 1. Part 1 will also have a connection to colleague 1, and this will be through composition, and there'll be exactly one of those as well. So if part 1 wants to instantiate a message, it will call colleague : notify with the message, and then notify will then send it to the mediator. The mediator will figure out who is going to receive the message. In this case, this is going to go back to concrete colleague 2. So that means concrete colleague 2 needs to have a reference to part 2, and it's going to be the same thing. Now, concrete colleague 2 will speak to part 2 through part 2's public methods. In other words, only concrete colleague 2 knows how to speak part 2's language, and only concrete colleague 1 knows how to speak part 1's language. Okay, let's take a look at an example here. We're going to go back to our company commander we had before. So we're going to have a company, which is going to be the mediator, and it's going to have a collection of platoons, 3 of them, in fact. And each platoon will have a reference back to the company. Now, there could be many different types of companies, but this one is going to be Alpha Company. So Alpha Company will instantiate the notify message. Now, there's going to be many different kinds of platoons, and each platoon will have its own instantiation of notify as well. So when I create Alpha Company, then I'm going to have to push back my red platoon, my blue platoon, and my green platoon, and now I'll have my collection of platoons. Now let's take a look at Alpha Company's notify. It's going to first of all log our message, so I have a record of every message that has ever been passed. And I'm going to say, hey, if this is a broadcast message, then I'm going to iterate through every platoon in my collection of platoons and call their notify message. However, if it's a specific individual message, then I will only give that message to that specific platoon's notify message. Let's look at another example, a video game. A video game contains many moving objects, each of which has a size and a position. When 2 objects collide, which is when the distance between them is smaller than the sum of their radii, then both objects are destroyed. In the current design, each object contacts every other object in the game to determine if a collision has occurred. Not only is there a redundant computation, object A checks to see if it's collided with object B and so on, but a host of optimizations are difficult to perform with this model. Okay, so let's take a look at a naive implementation. We have a rock, and the rock has a collection of rocks, and so I'm going to point to myself, and then I'm going to say was hit. And this allows me to perform hit detection between rocks. Now, I'm also going to have a bunch of ships, and the ships will be able to detect if they hit each other. But right now, the rocks will pass right through the ships, and the ships will pass right through the rocks. So I'm going to say have a collection of ships, and then I want to know if I'm hit from a ship, but I also want to do the same thing with rocks. So now ships and rocks can both collide with each other. Now I want to add bullets. Now the bullets can detect if they hit each other, but they can't see anything about rocks and ships. So what I want to do is I want to have a collection of rocks and a collection of ships, and was hit by a rock and was hit by a ship. And then the rock will also have to have a collection of bullets, and the ship will have a collection of bullets to see if we hit them as well. Now, as you can see, the number of connections I have increases polynomially if I add more elements to the game. Clearly not the best design. So let's try something new here. I'm going to have a ship which has collision detection, a bullet, and an asteroid as well. Now, each one of these is going to have a colleague, and that the asteroid colleague, the ship colleague, and the bullet colleague. Now, for an example, asteroid colleague : update will know to call asteroid : hit, whereas ship : update will know to call ship : collision. In other words, it's okay if asteroid, ship, and bullet have absolutely nothing to do with each other. They don't have shared interfaces. They don't have a shared base class. They have nothing to do with each other. But the colleague associated with a given game entity knows all about it. And there are relations between the two. For an example, the asteroid colleague has a reference to asteroid, where the asteroid has a composition to asteroid colleague. In other words, the asteroid will create or destroy the asteroid colleague object. How are asteroid colleague, ship colleague, and bullet colleague all related? There's an abstract colleague base class, and asteroid colleague, ship colleague, and bullet colleague all derive off it. And notice how the abstract colleague has a pure virtual function called update. And because it has a pure virtual function, it's an abstract class, and that's why we call it an abstract colleague. Okay, now we need to have the mediator. And the mediator is going to have an update, which will be able to call the abstract colleague and so on. And so the mediator has to have a collection of colleagues, and the colleagues will have a single mediator. And both of these are by reference rather than by composition, because we should be able to create and destroy them independently. Okay, so currently I'm going to have the collide, and the collide is going to implement update for the mediator. But the cool thing about this design, if I want to do other things such as draw, or I want to do score computation, or handle input, or whatever, all these guys can use the same mechanism I used before. This is example 44.1 in the mediator section of the message passing chapter of the software design textbook.